Chapter B, Coordinate System. Okay, now let's talk about a 3D coordinate system. We can represent the position of any point in three-dimensional space as numbers along three orthogonal axes, x, y, and z. This point is 2, 3, and 1. This is 1, 2, and 1. We call this a coordinate system because the position of any point can be represented by three coordinates. Now imagine that instead of having axes, we use unit vectors, vectors of magnitude 1 that point along the positive direction of each axis. We call the vector that runs along the x-axis the I vector, the vector that runs along the y-axis the j vector, the vector that runs along the z-axis, you guessed it, the k vector. We call this set of vectors, wait for it, the ijk vectors. I know it's not creative, but the professor I learned it from said ijk, so I'll say ijk. And my guess is that from now on, you'll say ijk. Imagine, instead of using axes, we use ijk vectors. Now this changes things in one very special way. Before, these numbers were just coordinates along the axes. Now, they are essentially magnitudes for the ijk vectors. So the first coordinate, 2, used to be a coordinate, but now it's the magnitude for the I vector. 3 is the magnitude for the j vector. And the magnitude for the k vector, you guessed it, is 1. Since these are unit vectors, we just have to do scalar multiplication to get the magnitudes. And that's why we use unit vectors. If the ijk vectors weren't unit vectors but some arbitrary magnitude like 1.2 for instance, then the scalar multiplication of 2 times the I vector would yield 1.2 times 2 equaling a magnitude of 2.4, and we would need to do some more math to get the magnitude down to 2. It's better just to use unit vectors because 2 times the unit vector I would just give a vector along the x-axis of magnitude 2. Once we have the correct magnitudes for the ijk vectors, we just sum the vectors, and that's the location of point 2, 3, and 1. Now you're probably thinking, JJ, you did nothing. The numbers are still the same. It's like everyone's saying there are 3 stones and you're saying, no, you got 3 rocks. It's the same thing. Yeah, all I did was change the meaning, but look at what this change means. If I start with a point A, and we change the meaning from coordinates to ijk magnitudes, then when I decide to rotate the ijk vectors, point A, as we can see by this diagram, gets rotated too in the exact same way. In a sense, point A does not know that it was rotated. All it knows is that its coordinates represent the magnitudes of 3 vectors. That's it. Think about that. It's incredible. That means that you could have thousands of points. It could be points of a skull. It could be a digitized skate. It could be anything. And you don't have to worry about rotating each and every point. You just rotate the ijk vectors, and all the points come along for the ride. Moreover, what this means is that you can represent an entire coordinate system simply by using 3 unit vectors.